Right, so this is another question on trigonometry, and what we are given is a triangle. So let me draw a triangle real quick, which has got three angles, obviously. So there's an angle A, so this is angle A, B and C. And let's assume that A is the smallest angle, and the next largest angle is B, and the largest angle is C. So what we are told is, we are told two things. The first thing we are told is that A, B and C are in arithmetic progression. And the second thing we are told is that the ratio of the smallest angle, which is A, when expressed in degrees, to the ratio of the largest angle expressed in radians is equal to 60 by pi. Right? So we are told these two things. And what we are being asked is, what are A, B, and C in degrees? Right? So you would recall that degrees and radians are two of the more common measures of angles. So we are being asked to express the answer in degrees, right? So let's see. Where are we now? So we have got these two facts, and let's see why they're important. So what can we take out of fact number one, the fact that they're in arithmetic progression? Well, if they're in arithmetic progression, then if the first angle is equal to A, if the A is equal to A, then B is equal to simply A plus something. And the next angle, C, is equal to B plus something, right? This follows from the definition of arithmetic progression. So an arithmetic progression is simply a sequence of numbers in which the difference between any two successive terms is a constant. So the difference between A and B is D, and the difference between B and C is also small d. And this small d is called the common difference. It's common to any two successive terms. So that's what we get out of the fact that A, B, and C are in arithmetic progression. And just as a note, the fact that C is equal to B plus D simply means that C is also equal to A plus 2D, because B is equal to A plus D. So this is what the relationship between the three angles is. As far as the second fact is concerned, so the second fact that we were told is AD by CR is equal to 60 by pi, right? So this is kind of important because this question really is about knowing what the relationship between radians and degrees is. So if we look at this, we basically have something which is in degrees in the numerator and something in radians in the denominator. So ideally what I would like to do now is I would like to express everything in the same units. So either both A and C in degrees or both A and C in radians. So I would like to do one of the two. But because we are being asked to express the answer in degrees, so let's just go with degrees. So what I would ideally like to do is have this ratio, a value for this ratio, A and C in degrees. But what I have is the ratio where A is in degrees but C is in radians. So so how can I go from here to here, right? So now here's something we know. Um, if if C is in if C is in radians, then how much is that in degrees, right? So if C is, let's say, pi by 4 radians, then how many degrees is that, right? So what's CD equal to? Well, the relationship between radians and degrees is simply pi by 180 times CD. So if an angle is C degrees, then in radians it is CR radians. It's pi by 180 times CD radians, right? So if something is pi by 4 radians, then it is equal to pi by 180 times CD degrees, which means that CD, the pi cancel, is equal to 45 degrees, right? So if I solve for CD, then I get CD is equal to 45 degrees. So so we can write now CR in terms of CD. So if we go ahead and do that, then AD by CR is simply equal to AD by pi by 180 times CD, right? Which we are told is equal to 60 by pi. So from here, what we get is the 180 goes up, so 180 by pi times AD by CD is equal to 60 by pi. Now the pi in the denominator is cancelled and 180 goes down over here, so this gives us AD by CD is simply equal to 60 by 180, which turns out to be 1 by 3. Right? So now we know that if A and C are both expressed in degrees, then the ratio of the smallest to the largest angle is 1 by 3. But the arithmetic progression bit of it also tells us something about what the ratio of AD and CD is. So what does arithmetic progression tell us about the ratio of the smallest and the largest angles? Well, that tells us that AD by CD is simply equal to AD divided by AD plus 2 times D. So this comes from arithmetic progression. But AD by CD is also equal to 1 by 3. This came from here. This came from the fact, this came from this ratio over here. So if we solve, then this implies that 3AD is simply equal to AD plus 2D, which if you solve will tell you that the smallest angle in degrees is equal to the common difference of the arithmetic progression. So the small d is equal to the smallest angle. Now why is this useful? Well, this is useful because it now allows us to find out what the other angles are, which is BD and CD in terms of AD. So BD was equal to AD plus D, but D is equal to AD, so this turns out to be 2 times AD. And this one told us that CD was equal to BD plus D, but BD is equal to 2AD now, so that's 2AD plus AD, and this turns out to be 3AD. So this is great because now we know that B is twice of the smallest angle and C is equal to thrice the smallest angle. We still don't know what A, B and C are, but at least we know what the relationship between A, B and C is, right? But remember one other thing. These are angles in a triangle, which means that AD plus BD plus CD has to be equal to 180 degrees, which means that AD plus 2 times AD plus 3 times AD has to be equal to 180 degrees, or 6 times AD is equal to 180 degrees, which implies that AD is equal to 30 degrees, right? So now we found the smallest angle, and therefore it's very easy to find out what BD is. So BD was just twice of AD, and so BD is equal to 60 degrees, and CD, which was thrice of AD, is simply equal to 90 degrees. So using the two facts that we were given initially, we've worked out that angle A is equal to 30 degrees, angle B is equal to 60 degrees, and angle C is equal to 90 degrees. So that was the question, and that's how it's done.